Chapter 9, Conic Sections. Section 9.1, the ellipse. It's kind of interesting in this textbook that Chapter 1, Section 9 is directly connected to Chapter 9, Section 1, because Chapter 1, Section 9 is about circles. And you have just practiced a little bit with circles and reminded yourself of their equations and how to graph them. And that leads us right into the conic sections, because a circle is a conic section. So on your notes, let's just add the first conic section, the one we know the most. It's the circle. And so the name, of course, circle, and there you see a sketch of a circle. But then the other conic sections are these. The parabola, and that's one that you know. You've worked with the parabola a lot. You are going to learn a few new things about the parabola in this section, in this chapter. But the parabola is another conic section. And then there are two that you've not seen very much of. The ellipse, which is, the common word there would be the oval, you know. And then the hyperbola, which has two branches facing away from one another. They're either going left, right, or a pair that go up, down. And as an individual, one of them looks like a parabola, but they actually aren't. It has a slightly different curvature than the parabola. So there are the four main conic sections, and today we're going to study just the ellipse and focus on the ellipse. The definition of an ellipse, here it is. An ellipse is a set of all points in a plane, the sum of whose distance from two fixed points is constant. An ellipse is a set of all points in a plane, the sum of whose distance from two fixed points is constant. Please copy that into your notes. Now, on the previous slide, you just saw what an ellipse looked like. We said it's an oval. So it's kind of curved like a circle, except it's elongated. One direction's longer and one direction is shorter. So the next part of your note says describe the major and minor axes of an ellipse and its vertices. So here is what those terms mean. The major axis is a line segment through the foci and center with endpoints called vertices on the ellipse. Let me read that again. The major axis is the line segment through the foci and center with endpoints called vertices on the ellipse. The minor axis is the line segment perpendicular to the major axis at the center with endpoints on the ellipse. So please write those two ideas about major axis and minor axis, and also vertices is there, and an ellipse also has a center, just like a circle has a center. So those vocabulary words are important. Okay? We have a major axis, and the endpoints of the major axis are the vertices, and then there's a minor axis. Those endpoints don't have special names. Where does the major axis and minor axis intersect? They intersect at the vertex, at the center, get that right, at the center, and they happen to be perpendicular to each other. Okay, so we're about to draw that. We're going to sketch it. So let's do this. Okay. we want to sketch and put in our major and minor axes. So please draw your X and Y axis, okay? And then these 2 points, the blue points you see here, are the vertices. And if I connect them, there's that red segment, that is our major axis. And the midpoint of that major axis is the center of this ellipse. It happens in this case to be at the origin. And then this green segment is the minor axis. So it's perpendicular to the major axis. It's shorter than the major axis. Its endpoints are on the ellipse, but they don't have special names. And here's our ellipse. And the other thing you notice that I have added to this diagram is this little side is A and that side is A. And going up here, this is B and the bottom is B. So that's a distance. And that will be part of our equation in just a minute that we'll use. Okay? So sketch an ellipse. Sketch the ellipse with the major and minor axis labeled and the center and vertices labeled. And then we want to write the standard form of the equation of an ellipse centered at the origin. Just like this one has its center at the origin, we want to do that. And so over on the right-hand side of your notes, you can write these two equations. There are two versions of it. Here's the first one. X squared over A squared plus Y squared over B squared equals 1. That's the first version. And then here's the second version. Or X squared over B squared plus Y squared over A squared equals 1. And in every single case, A is greater than B. Okay? That's kind of the giveaway of which one of those is A and B. A is the bigger one, so even when you square it, A squared is going to be bigger than B squared. Okay? So there's the versions of the equations. Those especially have the center at the origin. All right? Describe how you know whether the major axis is vertical or horizontal and how you know the lengths of each axis. Okay, well, you have to look at an equation to see. So let's move on to an equation here. Which denominator is larger? That's the answer to that. Which denominator is larger? Looking at this one, the denominator that's larger is the 64. The 64 being larger tells me that this one's going to be elongated in the y direction. So this one will be elongated up and down. When I look at the second equation, I look at the denominators and I see that 49 is larger. 49 is underneath the x squared, so that means this one will be elongated in the x direction, left, right. Okay, so that answers the question there. You'll have to put that in your own words. Which denominator is larger? It's elongated in the x direction if that larger number is under the x. It's elongated in the y direction if that larger number is under the y. And that's going to be your major axis that we've kind of given the arrows for there. Those will be the major axes. Now, let's begin to graph. Okay? When you get an equation, you're going to want a couple of values. You're going to want to know what A is and what B is. And I've already given direction here. That's the third thing you definitely want to know. Okay? So, the larger denominator is 64. A is the square root of that number. So the square root of 64 is 8. The smaller denominator is going to be b squared, so the square root of 25 is 5, so b is 5. Now let's come over to the graph. And all we have to do is look at this arrow and see that this arrow tells me that this is elongated up and down. So that means that the 8, which is the larger one, is going up. So from the origin, I'm counting up 1, 2, 3, 4, 5, 6, 7, 8, and I place a point. And then I'm going to count the opposite direction down. 1, 2, 3, 4, 5, 6, 7, 8, and there is a second point. Those are the vertices of this ellipse that we're about to draw. Okay? And then in the opposite, the other direction, perpendicular to those directions, okay, left, right now, we're going from the origin to the right 5, 1, 2, 3, 4, 5, that's the B direction, B distance, and to the left, 1, 2, 3, 4, 5, there we go. And now we're just going to connect these in the most beautiful elliptical shaped, curved shape we can make. All right? They're not always going to be beautiful. They look like eggs a lot of times. But you just do the best that your hand can do. The only thing I ask you is do not let it look like a rhombus. Don't connect straight to each point. Do not do that. That's not an ellipse, okay? So now that's pretty good. You can see that the major axis, I'm going to highlight it here. Here's the major axis. This piece is 8 and this piece was 8. And then the minor axis, the other direction, here's the minor axis. This piece is 5 and that one's 5. Now, those do not need to be drawn in. I was just highlighting them the first time we got an ellipse on the page, okay? And here, this point right here is a vertex, and this point up here is a vertex. So I'll just call it V sub 1 and V sub 2. And the center is the origin, okay? Just call it C. So there are the interesting things about it. But again, you do not have to put those on there when you're graphing. Only what I drew in red, and I'm probably going to remove them before we start the next one because we want to do the next one on the same graph, okay? So let me get rid of these things quickly. Voila. Now, going to the next one, x squared over 49 plus y squared over 36 equals 1. We need A and B. If you have another color, it's nice to just do this other one in another color if you have a chance. Which one of these numbers is A? Oh, it's A squared. The 49 is A squared, so A has to be the square root of that, 7. So 36 is B squared, so the square root of that is 6. Now, we saw that right here, this is elongated. The longer one was under the X, the larger number was under the X, so that's why we get A is the 7. So it's going in the left-right direction. So from the center, I'm over here at the graph now, going to the right 7, 1, 2, 3, 4, 5, 6, 7, and to the left 7. And so how far up and down will we go? Hope you said 6. 1, 2, 3, 4, 5, 6. And down 6. And now I have a different set of points. And now we'll connect these in the best ellipse that you can make. Okay? It's kind of a neat combination of those two there, I think. Now, let me let you know, there are two foci, which is the plural for focus. Foci. And the book talks about them, your worksheets might talk about them, the directions on the test or quiz might talk about them. We're not going to worry about foci. So anytime it says anything about foci, you just ignore it, okay? The order pairs for them, I think we even have part on these notes that talks about it, maybe, or not. It's the vertices I see. Okay. But you will not have to worry about the order pairs for foci, nor the order pairs for vertices. Okay? We're just graphing. You need to find A and B and know the direction. Okay? Moving on. this, two ellipses centered at the origin. Now, on the back of your notes, there's a table that asks you for the equation, and this equation is where
Roger and Sandra, could you mind coming over to Ms. Thompson's office real quick? I just need to chat with you. Sandra Rogers, thank you.
I apologize for that. The equations where the center is not at the origin. So you see right here, here's an expression you've seen before, x minus h. Here's y minus k. So those expressions you've seen before, and we're going to use them again. They are used here in this equation for an ellipse. So here's the equation for an ellipse that is has a horizontal major axis, so that goes in the major axis column. Here's the formula. Copy that one, please. And the center is HK. Center is HK. Then the second version of this has the a squared underneath the y minus k, so that gives you the larger value here, so that makes it be vertically aligned. And the center would still be HK. So this is just an example. Don't write that one on your paper. Fill in those columns. And then under the graph, let's just do a little XY axes. Let me make that a little bit larger there. And we'll just throw in a little ellipse that is elongated horizontally there, and we'll put one in. See, this vertex is not, center is not at the origin, so just get it away from the origin there, okay? So sketch those as your graphs. And you can see here in this example written in red that we've got x plus 2 quantity squared over 16 plus y minus 1 quantity squared over 9 equals 1. And you don't have to write this one down. I don't know if that's, let me look and see if that's the next one on your page. No, it's not. But so let's just decide, what is the center of this? It's HK. So that means I look right in here and I find H. What is H? -2. Look in the y part of this equation and find the k. What is k? It says y minus 1, so it's the opposite of the minus 1, a positive 1. So there's the center. And then if I need a and b, I would need a and b. Which one of these is a squared? The 16 is a squared, so a has to be 4. That makes 9 the b squared, so b is 3. And so if we were graphing this one, and I'll just do a real quick hand of this one because we'll graph the next thing very nice and neatly. We go to -2, +1. There's my center. And from that, A is elongated left-right, so we're going to go to the right 4. So there's 1, 2, 3, 4. There's a vertex. And 4 the other way. 2, 3, 4. Okay. Then we go up 3. 1, 2, 3. Down 3. That's 1, 2, 3. And so here would be this ellipse. Pretty ugly. Looks like a football. Okay. But you get the idea that the center's not at the origin, but you still, from that center, you count left, right, and up, down. Your distance is A and B. Okay? So let's move on very quickly to the next example. General form for an ellipse, general form for these conic sections is ax squared plus cy squared plus dx plus ey plus f equals 0. You do need to write that somewhere. It says put the following equations in standard form by completing the square and then making one side equal to 1. Write that standard equation right under that so you at least have it written on your paper once. Okay? And then we're going to do these two examples. Okay? All right, 9x squared plus 4y squared minus 18x plus 16y minus 11 equals 0. Notice one side in standard form is 0. But when we get it into the form for the conics, the ellipse form, There's a 1 on one side. So you'll see how we do that in a second. All right. It said to complete the square. We're going to complete the square actually twice. So we're going to bring our x terms together. 9x squared, and then bring the negative 18x with it. Leave some room. I'm going to kind of put those in parentheses. Plus, and then my y terms. 4y squared, and then the linear one, plus 16y, and a little bit of room. That constant, negative 11, I don't need it on this side. I want it on the other side. So I'm just going to go ahead and add it, and so it just jumps on the other side. It's on 11. There we go. Okay? Now, when we were completing the square, the first thing you did, you just looked in there, looked at the coefficient of the x, and looked at that 18 and started working. But wait a minute. There's a problem. The problem is this. There's a 9 right here, and there's a 4 right there. And you cannot complete the square with a coefficient in front of your squared term. It's supposed to be 1x squared or 1y squared. So we must factor out this lead coefficient of the quadratic term. So we are now going to factor out a 9, and so that leaves x squared minus, what will this be? If I factor out a 9, that's a minus 2x, leave some room, plus, and now on this second set, I want to factor out what number? We need to get rid of that 4. That 4 has to come out. So I factor it out. I got y squared. It also has to come out of that 16y, which leaves 4y. And some room equals 11. Okay, back up, take a look, see what we did. We factored out the lead coefficient of the x squared term, the 9, carefully. Then we factored out the lead coefficient for the y squared term, 4. Now we can complete the square. Looking inside the parentheses, we have the linear coefficient of a 2. Half of 2 is 1. 1 squared is 1. So I'm going to add a 1 in this parentheses. But hold on. If I add something in on one side, I have to do it on the other, right? But that's really not a 1. You look out front, and there's a 9 up here. And so that 9 essentially is distributed to that 1. So I've really added a 9 to the left-hand side. So what do I have to add to the right? I have to add a 9. Okay? So look at the next parentheses. I've got a 4y. So the coefficient of the linear term is a 4. Half of 4 is 2. 2 squared is 4. I add a 4 in here. But is that really a 4? Not really, because there's a lead coefficient, coefficient up here, and it's distributed to that 4, and that's not a 4, it's really a 16. So we're going to add 16 in the parentheses, on the other side also. So really, we added a 9 to the left in green, and a 9 to the right. We added a 16 to the left in blue, because 4 times 4 is 16, and a 16 to the right. Now, let's complete. We have a 9 out front, and this is x minus 1 quantity squared. 4 out front, and that turns out to be y plus 2 quantity squared. And we need to add everything on the other side. That looks like that adds to be 36. Okay? Now, look at the right-hand side. What did we say at the beginning when we started this, that right-hand side needed to equal? If you look back at all the ellipse formulas you've written down, all those general ellipse formulas, the right-hand side was a 1. How do I make a 36 become a 1? And the answer is not subtract 35. Divide by 36. So we're going to divide the right-hand side by 36 and the left-hand side, which essentially each of these terms gets divided by 36. Okay? Any questions there? I guess you have to ask somebody in the room. Sorry. That's just such a habit. Here we go. Now, You see the 9 over 36? What does that reduce to? 1/4? Okay, so we've gotten rid of the 9 in the numerator, and we've got x minus 1 left in the numerator and a 4 in the denominator. Okay, so 9 canceled the 9, 9 went into 36, 4. Look at the next fraction, 4 over 36. So 4 cancels the 4, and 4 goes into 36 9 times, and that leaves y plus 2 quantity squared in the numerator. And 36 over 36 is 1. All right, there we go. That is our equation of an ellipse. Gone from standard form to ellipse form. Okay. Can you tell me what our center is? We found our center. 1, -2. What's the value of A? 3. What's the value of B? It's a 2. And now, which way is this elongated? Up, down, or left, right? It's elongated up, down. So you're going to count up 3 and down 3. And you're going to count left 2 and right 2. Okay? Now, I know there's a graph over there, but you don't have one on your paper, so we're not going to graph that. Let's look at the second one. Can you do this one by yourself? Try it by yourself. At least start it by yourself. Look at the clock, and I'll give you a minute and a half. Should play some music. Okay, that doesn't sound very good. Let's try another one. A little bit of nature. I hope you're working on the problem. Okay. So here's my work. You can compare your work to it. (9x² minus 54x, bring the x term over. And then the 25y² plus the 50y, bring those two together. And the -119 goes to the other side, it's positive. Then we need to factor out the 9 and factor out the 25. Very carefully, that leaves you a -6x right here. And then factor out the 25, and that leaves you a 2y in this location. And so half of 6 is 3. 3 squared is 9, but that's really not a 9. It's 9 times 9 and gives you 81 over here. Then in the second parentheses, you got a 2. So 2, half of 2 is 1. 1 squared is 1. But that's not just a 1. It's 25 times 1, so that's a 25. Adding these numbers on the right, you get 225. Doing our factoring here, we get x minus 3 quantities squared with a 9 in front. We get a y plus 1 quantity squared with a 25 in front. And then we see we need to divide by 225 all the way across. So 9 goes into 225 25 times. 25 goes into 225 9 times. And then the 225 over 225 is 1. So let's graph this one to finish up. Help me with the center. What's the center? Center is 3 and negative 1. Which one of these denominators is a squared? The 25 is, so the square root of that is 5, and the square root of 9 leaves a 3 for b. So graphing, 1, 2, 3, negative 1, there's our center. And which way is this elongated? Up, down, or left, right? It's left, right, because the larger number is underneath the x. So from this center, I'm going to the right 5, 1, 2, 3, 4, 5. Left 5, 1, 2, 3, 4, 5. And then up 3, down 3, and there is the ellipse. Okay? Almost football. Sorry. Shouldn't be pointed on the ends, but it's not exactly there. Okay? All right, so hopefully you've gotten, you understand the way the equation is set up. You see where to find the major and minor axis, the numbers to give you those distances. You understand where to find the center. And now you see how to take a general form and turn it into our standard form. So maybe I said that backwards. I'm not sure. All right, here is your assignment. Please copy it carefully. You do need a piece of graph paper, and enjoy.